we got a lot to cover. I just got the quizzes. They're in my office, so I'm gonna take them home and grade them this weekend. And we'll go over it in detail on Monday. Today is all about hypothesis testing. All right? We just got done with confidence intervals. Remember how we calculate the confidence intervals? Didn't realize I'll have to sign. How we calculated the confidence intervals. Well, now we're doing hypothesis testing, which is very similar. The difference is now that we have a sample mean and a hypothesized mean. And we're going to learn 3 different ways. There's 3 different formulas we're going to learn in the next 3 weeks. One of them is going to be where you're reading the sample mean is being given and the hypothesis mean is being given, but you also notice there's a population standard deviation, just like confidence intervals. Population standard deviation, you know then to do Z. Next week's all about a sample mean and a hypothesized mean, but you're not given the population standard deviation, you're given the sample standard deviation. Instead, you got to know to use T. This all should sound familiar to you, just like the confidence intervals. And the third one's proportions, where there'll be no standard deviation, just like the confidence intervals, and you know to use Z. All right. Now, we already talked about last week how to find the critical value, Z or T. We talked about those Excel equations. But this time, the Excel equations we're using is to find what's called the p-value. So we're going to be calculating what's called the test statistic based on one of these 3 formulas, and the one here is this week's, where we're given the population standard deviation. That's all that's on this homework for this week, is this first one right here. So you know what formula to use for the homework. It's right here. You take the sample mean minus the hypothesized mean. You got to go in this order. So this way you'll know if you have a negative or a positive test statistic. This is the big part of it. The denominator is the population standard deviation, because we're only doing this one right here with the population standard deviation, divided by the square root of the sample size. This is how you get that test statistic. Now, there's a slightly different formula next week when we have the sample standard deviation, and there's a really different formula the week after that when we're doing proportions. This is if we're given the population standard deviation. And remember, this is very similar to confidence intervals, but in this case, we have a hypothesized mean and a sample mean. Right? We're not doing, well, I take that back before I say those words. All right. Now, the Excel equation to find p-value is right here. This one is the one we use when you calculate this to be a negative test statistic. Let me repeat that. If this turns out to be negative, you're using this top equation. Equals NORM dot DIST, parentheses, negative test statistic that you just calculated is the first number in the parentheses, comma 0, comma 1, comma 1. And then you got to ask yourself the question, is this a one-tail or a two-tail, which you're going to learn today how to figure that out. Is this a one-tail or a two-tail? And if it's two-tail, you multiply the result by 2. Now, you calculate this test statistic, it ends up being a positive number. You do this equation, equals 1 minus NORM dot DIST. The positive test statistic's the first number, comma 0, comma 1, comma 1. And then the same question, either you have your p-value right then, if it's one-tail, but if it's two-tail, you have one more step, multiply by 2. Now, this approach I just talked about is this first approach called p-value approach. Next week, we're going to also learn the critical value approach, and I may even talk about the confidence interval approach, but the confidence interval approach you really already know. Well, the last 3 weeks you've been doing confidence intervals, and it's just like the same thing here. You're going to do a confidence interval, but you have one additional step after you do your confidence interval. And that step is, you have to ask yourself, is the hypothesized mean fit in the confidence interval I just calculated? Now let me repeat that. You ready? We're not going to do the confidence interval approach on the homework, and you're going to hear me repeat this next week. But I want you to understand how easy this approach is, because you did it for the last 3 weeks. you're gonna calculate a confidence interval just like you've been doing the last 3 weeks, and you got your two numbers, your upper interval, your lower interval. And then you're gonna say to yourself, does the hypothesized mean fit within that upper and lower interval number? If it's between it, you can't reject. If it's outside of it, you must reject. Now, what do I mean by reject? Here's your two, this is now going back to the p-value approach. The first one, p-value approach, that was confidence interval approach. We're gonna talk about it again next week, so don't worry if you missed anything on that one, but focus on this p-value approach, because this is how you're doing your homework. You gotta do the p-value approach. You're reading the problem, you're going, okay, I know it's this formula right here because this week is only given the population standard deviation within it. You know to take the sample mean minus the hypothesis mean. You know to take that population standard deviation divided by the square root of the sample size. You got your test statistic. Now here's what's new. You're now taking that test statistic, plugging it in one of these two equations. You're then found the p-value, unless it's two-tailed. You got to multiply times 2 then. Now you found the p-value. So you either did or you got that extra step. We're about to learn how to determine that. Then you take that p-value and you ask one of these two questions. Is it less than the significance given? Or is it greater than equal to the significance? If the p-value is less than the significance, you must reject the null hypothesis. This is your conclusions for this week. The homework says, tell whether to reject or not reject the null hypothesis. And here's how you're going to determine. You're calculating the p-value, and if it's less than the significance, you say, we are rejecting the null hypothesis. But you calculate that p-value, and it's not less than, it's either equal or greater than the significance, you are gonna write, we cannot reject the null hypothesis. We cannot reject the null hypothesis. And I just fed you with a whole bunch of information. But we're gonna go over some examples so you can see exactly how this is done. First of all, let's talk about the null and alternative hypothesis. You're gonna read some problems, I'm about to show you some examples, and we have to come up with the null and alternative hypothesis. Now here's what the deal is. The null is always represented with an H with a little O. Big capital H with a little O, that's null. The alternative is a capital H with a little a. That's the alternative. The null hypothesis is what the researcher or whatever this problem's about is not trying to prove. They're saying this is the assumption, this is what that we think might be true, it's not what they're trying to prove. The alternative hypothesis is what whoever's doing the problem, if you read it, it's what they're trying to prove. The point they're trying to make is the alternative hypothesis. All right? Now, here's a rule. The null hypothesis always has an equal involved. The null either is equal, then that makes the alternative not equal. The null could be less than equal, but it has to have the equal. The alternative would then be the opposite, greater than. And the null could be greater than equal, again it has the equal. The alternative would be the opposite, which is less than. These are your three options, that's it. And if it's equal, not equal to, you just wrote a two-tailed problem. Equal, not equal to. Let me make sure you understand what I mean by that. Look at this bell curve. Here's the null, the mean of the null hypothesis is the mean, we're in the middle of the bell curve. And what we're trying to do is, when we say equal, we're saying, okay, hey, we think, I'm gonna use, I think this may be on the PowerPoint. You work at, name a cell company, Mint Mobile. I don't know why I said Mint, who cares? Mint Mobile, you work at Mint Mobile, and you're at one of the regional places, and you're saying, look, we have thousands of customers here. And you're saying the average monthly fee for our customers here at Mint Mobile is $35 a month. $35 a month. And someone else says, no way. Matter of fact, I'm gonna prove it's not $35 a month. But here's the deal. In research, using statistics, to prove it's not 35, we're gonna make this 35. There it is, this is what the person claimed at the regional office. The average cell phone bill is 35, and you're saying no, it's not 35. But in statistics, to prove it's not what has just been assumed, the 35, your sample evidence has to be so far away from 35. Let me show you. Think of all the numbers on the number line that on this circle. 35, 36, 37, 38, or something like 34, 33, 32, depending on the standard deviation, but you get my point. There's a lot of numbers there. For you to prove that it's not 35, the sample results have to be way far away, or you really didn't prove it. That's the whole point of using statistical research. That you're saying this sample, you went ahead and said, we're gonna pull out the 50 out of these thousands of customers right here. Let's randomly choose 50 right now. And somehow you come up with a process, and this is the key to research. Every one of those 5,000 have to have an equal chance to be one of the 50s. And you came up with a process to pull 50 of them out of there. And you go, here we go, let's add these 50 up and divide by 50. The average cell phone bill per month has to be so far above 35 or so far below 35 for you to prove your point. Or you didn't prove it. Randomness could have made it a little bit above or a little bit below because you only took a sample of 50. It has to be far away for you to prove your point. So it's kind of hard to have a research project to prove your point because you got to be so far away from what's assumed. That's what the p-value is. The p-value is it's showing you, compared to the significance, how far away the sample results ended up being. And that's why the probability of getting that sample mean, let's say we got, I'm gonna pull a number out, hang on. This 35, let's pretend right over here is 30, no, 29. Why not? 29. Your sample results ended up being 29. And sure enough, we calculated all this because it's way down here. We probably got a negative something here, maybe a -2, who knows. We go here, we put the -2 right there, we get this. Since we're talking about both sides here, that makes it 2 tail. We multiply it times 2, and then we go right here. What we just calculated is, what's the probability that our sample ends up being way down here, this far away from 35? What's the probability of that happening from luck? And this p-value says, oh, there's only like 4% chance that luck made that happen, which means there's about a 96% chance that it's trying to tell you that it's not $35 a month, that the average cell phone bill for our customers, if we had time to add all thousands of them up and divide by that many, would be 29. Because our sample's so far away from 35, it can't be 35. You proved your point. And when that p-value is so low that it's below the significance, you can reject the null. The null would be the average cell phone bills equal to $35. And since you can reject the null, you're just proved that the average cell phone bill is not 35. Matter of fact, our sample results ended up down there at 29. You get it? Now here's the deal. I want to make sure you remember significance. If I said to you 90% confidence, how much significance is there in that problem? 10%, exactly. If I said 98% confidence, how much significance? 2%. If this is something that's very important, average cell phone bill is not that important, but let's say this is, University of Michigan was one of the research centers for the nation back when COVID hit for the vaccines. And it was very important to prove these vaccines truly affected COVID patients that could have received COVID. So the results on the study had to be less than 1%. If I said 99% confidence, you tell me the significance is 1%. The results of the study had to be so far, here, right here in the middle is that, oh, the vaccine doesn't have any effect on humans trying to stop COVID from hitting them. But they were able to prove way down here, and it was 0.5% per tail. 0.5%, because 1% divided in half. 1% significant. And they were able, and they said, no, these vaccines, there's no way these patients getting the vaccine compared to these patients who thought they were getting the vaccine could have that much difference. Now this is called 2 sample. This is what we're going to, after these 3 weeks, we're going to 2 sample. There's no way these 2 samples could be this much different unless that vaccine was truly doing something. They had to prove it without a shadow of a doubt for it to be approved for humans to be able to get this vaccine. Now don't get me wrong, I know there's people who say, oh, the vaccine side effects, oh, it's gonna lower IQ, or whatever the things that have not been proven, but whatever's going on. As you know right now, by the way, in the Senate, they are interviewing what possibly could be the next head of all the departments of health and FDA and all the approvals. And that's going on right now. And it happens to be somebody who believes that we should never have vaccines, wants to even take away the polio vaccine, even though there's statistical evidence that that vaccine, without a doubt, it was so far in the tail, without a doubt, that it was providing a benefit to the humans. Now, I have an open mind, so I listen to all arguments, but I just want to say this is how statistical research works. So now, these problems aren't going to be so big deal. It may be a cell phone bill, so a cell phone bill is not that important. So the significance will be higher. The threshold to prove whether it truly is $35 or not won't be as far into the tail. It might be closer to 35 from either direction. 10% significance maybe, even 15% significance. Here's the deal, here's the hardest part. You have to start your homework by being able to write a null and alternative hypothesis and recognizing it. And it goes like this. The null hypothesis is going to receive one of these and then a number. Maybe the mean, maybe the proportion. The alternative hypothesis, matter of fact, I'm going to show you one. Here's a null, mean. They use symbols in your book and the PowerPoint, but I use words so you make sure. The mean, and then let's say it's a two-tailed, equals, and then I'm going to put a number here. I'm just putting a number right now, question mark number. The alternative, mean, is not equal, and then some number, whatever the hypothesized number is, what the assumed number is. And then you're probably trying to you are trying to prove that that number is not true. Your goal as a researcher is to say, I'm going to analyze this data because the whole reason I want to do this research is because I don't think this is true. And so this is why I want to do a sampling to see if it's far enough away from this to prove my point that this is not true anymore. Do you get it? This is what motivates people to do research, is because they believe something that we all believe could not possibly, maybe isn't true. Matter of fact, it's been a long time since we've taken a sample, so let's take a sample and see what the results are. If the results are so far away from that null hypothesis mean, then you just prove that that's no longer true, that something else is going on. Now, I want you to write the null and alternative hypothesis out loud. Hang on, I want to make sure I find it. There we go. Here we go. Some of these are hard. Are you ready? A research analyst disputes, so the researcher is disputing, a trade group's prediction that back-to-school spending will average $606.40 per family this year. The researcher, she believes that average back-to-school spending will differ from that amount. There was the key word, differ. It didn't say she believed it's more than that. It didn't say she believes it's less than that. Those two words would have been a one-tail. She said it's different than 60640. That's what makes it two-tailed. You get it? She wasn't claiming it's more, wasn't claiming it's less. She's claiming it's something different, meaning it could be more, it could be less. And that makes it two-tailed. So here it is. This would be an equal, not equal to. The null hypothesis is equal to, what was the number, 60640? This number would be 60640. The alternative hypothesis is that the mean's not equal to 60640, that the researcher believes that it's either less or more, that it's something different. Now, if all of a sudden we do our research and we get 60740, we probably didn't prove it's different. It's got to be so different, depending on the significance given, that you're proving that the sample's saying, hey, look, the sample's telling us it can't be 60640 anymore, because look how far away this number is than 60640. It's so far away. And this is the calculation to prove just how far away it is. And then this. So, there's our first one. Let's see if I got it right. The null hypothesis is equal to 60640. The alternative hypothesis is that the mean's not equal to 60640. All right. Your first two homework problems is where you are reading it and you got to write both the null and the alternative hypothesis based on what you read. So let's do another one. in general, it is generally believed that at least 60%, and be careful, these are from, this could be any three of these. I don't know what this could be any three of these. It is generally believed that at least 60% of the residents in a small town in Texas are happy with their lives. A sociologist, thank you, wonders whether recent economic woes have adversely affected, page 328, obviously I was copy and pasting this. Boom. Let me save. I already posted that, so ignore that when you guys download this, because I posted these for you. Adversely affected the happiness level in this town. Specifically, the null and alternative hypothesis to specify the null and alternative hypothesis to determine if the sociologist's concern is valid. Now let me read this again because I confused myself here. Here's the key words right here. I can see it in the first sentence. It is generally believed that at least 60% of the residents of a small town in Texas are happy. What is the researcher saying? That she or he believes that, no, wait a minute, I don't think at least 60% are happy. I don't think at least 60%. So this is a one-tail. Notice it doesn't say equals 60%, and the other one doesn't say not equal to 60% or different from 60%. This says at least 60%. So here we go. Here's the null. The null proportion is, this one isn't a mean, it's a proportion, is greater than equal to 60%. Notice the equals on the null hypothesis. It always has to be on the null. Greater than equal, because the words at least 60%, that means 60% or more. The sociologist is saying, no, I don't think that's true anymore. And so the alternative would be that the proportion is less than 60%. This is a one-tail. And notice what the sociologist is trying to prove is the alternative. And we'll learn that formula 2 weeks from now so that you can calculate that. It'll be just like this. You're going to get a test statistic Z. You're going to plug it in one of these two. It's the same exact formula here. This is being used for all three of these. One of these two formulas, you found the p-value. You determine if the p-value is less than the significance. If it is, you reject the null. What are we rejecting? I'm rejecting that at least 60% of the residents of the small town in Texas are happy. I'm rejecting that because my p-value was less than my significance. You get it? And therefore, the alternative, that the citizens of the small town of Texas, it must be less than 60% are happy because of the economic woes. The sociologist was correct that the attitudes have changed. If that's how it turns out. Or the sample results, hey, we sampled 40 residents from the town. We asked them if they're happy or not. Out of 40, 20 of them said yes. What is that? That's 50%. So now we would go 50%. Well, no, this isn't the formula. When we get to that formula, it'd be 50% minus the 60%, blah, 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 blah. Let's do another. Whoop. Suppose the sociologist wants to establish that the mean retirement age is greater than 67. One tail or two tail by that sentence? One tail. Greater than 67. Suppose the sociologist wants to establish that the mean retirement. Now this is saying they want to establish that it's greater than 67. It is assumed the retirement age is normally 67 or less. Okay, remember, the alternative is what the researcher, the sociologist, or whoever this is talking about, is what they're trying to prove. The null is what's assumed, is the opposite of what they're trying to prove. In this case, the null would be 67 or less, equal or less than 67. The alternative, what they're trying to prove, is that the mean retirement age is greater than 67. So this would be, here it is in writing, the mean for the null is less than equal to 67. The mean for the alternative is greater than 67. Now this is exactly how you do the first part of your homework, is you're writing the null and the alternative hypothesis, and since we're only doing this one, you know it's going to be H sub O mean, H sub A mean. For every answer where you got to write the hypothesis, it starts like that, because we're not doing proportions this week on the homework. So you know it's going to be mean. You then have to, this is where you got to decide. Is it a one tail or two tail? Is this the less than? Is this the equal? Is this the less than equal? Is this the greater than equal? Is this the not equal to? Is this the less than or is this the greater than? You gotta figure that out. And what number is on the right side? That's what you gotta do for your homework. Everybody get the first part? Everybody understand what's expected? Writing the hypothesis. All right, we got that part. Now that we have the hypothesis figured out, we're gonna calculate whether, once we get the sample data, we're gonna calculate whether we can reject the null or not. Is this sample data significant enough to allow us to reject the null? So let's get to our first one. So here's just what a null hypothesis is, blah, blah, blah. Here's, it says the null hypothesis has to contain the equal, the less than equal, the greater than equal. It's the only three things that can be in the null. You have to have the equal and the null. We either may or may not be able to reject the null. The words are always about the null. Can you reject it or not reject it? Don't accidentally say, oh, I accept the alternative. It's all about the null. Can you reject or not reject the null are the words of the answers. All right? Blah, 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 blah. You guys all read this before you got here. Just checking. Significant levels, most typical ones for significance. And don't get fooled. You're not always given the significance. Sometimes you're given the confidence, but you know how to turn the confidence into a significance. Matter of fact, let's do the opposite. The typical values for significance are 1%. What's the confidence? 99. The typical significance is 5%. What's the confidence? 95. The typical significance is 10%. What's the confidence? 90. You got it. So if you see a 90, you know it's a 10. If you see a 95, you know it's a 5. These interchange, so some problems will be given confidence, some significance. Don't let it fool you. You got to use significance when it comes to the p-value, which is this week's homework all about p-value. So you know you got to use significance to compare with. Now, let's get to it. Blah, 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 blah. We're not doing type 1, type 2 errors this week. We'll talk about them, but not this week. Blah, 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 blah. Okay, here's 2 of the formulas out of the 3. When the population standard deviation is known, that's that first one. This is all about this week's homework. This is the main one this week right here. This is the one we're doing. This is it right here. The other one that has to do with the mean is when you don't know the population standard deviation, but what you will be given is the sample standard deviation. So you got to look at, when we get past this second quiz, it's all about your given problems where you have a hypothesized mean and then you're getting a sample mean, and you got to decide which one of these 3 it is. Do I have, you're going to, same as you did with confidence intervals, do I have the population standard deviation? Am I being given the sample standard deviation? Or is there no standard deviation? And then you know which formula to use. Let's talk about that first formula right there at the top. This is on slide 14, so I'm going to put this right here. This one is slide 14. And there it is in variables, what I have in words here. The sample mean minus the hypothesized mean is your numerator. You've got to do that first. And then you got to do the denominator before you divide, order of operations. Let me say it again. Do the numerator, then do the denominator, then divide. In the population standard deviation, which will be given to you, over the square root of the sample size. Now divide that into the numerator. By the way, this numerator determines whether this z or t, if we're doing this next week's, is a positive or negative, which then determines which one of these to use. If it's positive, you got to put that 1 minus in front. If it's negative, you don't put the 1 minus in front. See the difference? All right, and that's all based on this little subtraction right here. If this numerator ends up being negative or positive. All right. I want to get to an example here. Here we go. We're going to test the claim, if it's true or not, that there is an average number of TVs equal to 3. Equal to 3. Now you're the researcher and you're saying, you know what, I don't think there are an average of 3 TVs per household. So think about the null hypothesis and the alternative. The claim is that there's an average of 3. The researcher is saying, I don't think there is an average of 3. I think it's different. Nothing about it being more than 3, nothing about it being less than 3. It's just 3. That's why it's two-tailed. That's why you have the null hypothesis mean equals 3. Alternative hypothesis, mean doesn't equal 3. Look at this, PowerPoint's using a 1 instead of an A. The book uses an A, the PowerPoint's using a 1. Just go with words. That is a two-tail. This is the only one that's two-tail. Equal and not equal to. The other two are one-tail. But the words were equal to 3, not equal to 3. So there we go, we got a two-tail. Now, here's what I want to point out to you. Because it's two-tail, we have that extra step here. When we calculate this, we got to multiply it times 2, and then compare the significance. Let's keep reading. Says, specify the desired level of significance in the sample size. Okay, we went ahead and called 100 random households. And this is, let's say, does this say US? Yeah, it's in the US. So we had to get as many phone numbers as we can. Maybe a couple million phone numbers. We had to mix them up and pick out 100 of them and call and say, hey, how many TVs do you have? There's our sample. We did our sampling. And we're saying 5% significance. This means that the sample data has to be so far away. Now this time, the null is a 3. The sample data has to be so far below 3 or so far above 3 that, let's see, it's this two tails, so 5% means 2.5% here, 2.5% there. The results have to be in those little 2.5% tails for us to be able to reject the null. For us to say, no, you're wrong, there aren't 3 TVs per household. It's something different. But if our results are too close to 3, I don't know, 3.1 or 3.2 or 2.9 or 2.8 or 2.97, depends on the standard deviation and sample size. But if it's too close to 3, we can't reject the null hypothesis. Our p-value is not going to be less than the 5%. We know right now on this problem that we're comparing to 5%, 0.05. Because it's given to us, 5%. And if our p-value is less than 5%, 4% or 3% or 4.5% or 3.5%, we're rejecting the null. No, the average number of TVs is not 3. But if our p-value is 3% or 3.5% or 4%, we can't reject the null. Randomness could have caused us to have slightly different, and we didn't prove anything. And so we have to accept, there's probably 3 TVs per household. You ready? We called up 100, asked them how many TVs, we add them all up, divided by 100, and what did we get? 2.84. There's our sample data. 2.84. So you take that sample mean, 2.84. Now this is a large sample size, so 2.84 doesn't look far away, but because our sample size is so large, it is kind of far. 2.84 minus the hypothesized mean, remember that's on the right, the hypothesized mean, 3, gives us a negative 0.16. Now we know our test statistics is going to be negative, just because of that numerator. We know we're using that top p-value formula. Divided by, the standard deviation says right here, oh, I must have not read it, but up above it said that our population standard deviation was equal to 0.8. It said population standard deviation, that's why we're using this formula. We take that 0.8 divided by the square root of 100, which is 10. 10 to 0.08. 0.16 negative divided by 0.08 is negative 2. How convenient. Here we go. Equals norm dot dist. Negative 2, comma, 0, comma, 1, comma, 1. Here we go. You ready? Equals norm dot dist, parentheses, was that negative 2? Comma, 0, comma, 1, comma, 1, parentheses. Are you ready? Our p-value is just a little over 2%, 0.02275. What, am I doing something wrong? Am I forgetting something?
No.
Oh, darn.
Multiply by 2.
There it is. There it is. That's what I was hoping he was going to say. I got to multiply by 2. This is a two-tail. Hang on. Go ahead.
I was just wondering where you got the sample mean from, because it wasn't on the other slide.
No, it was given in the story at the top here, I think, or where was it here? Hang on. I think it just gave it to us right here. Number 5, collect the data, compute the test statistics. Suppose the sample results were 100 sample size, 2.84 sample mean. But it will be in the story. I'm going to read one to you before you leave so you can see how it's given to you in the story, okay?
Okay, thank you.
But there it is there, 2.84. We calculate negative 2. We entered it into the top Excel equation because we had a negative test statistic. We just found the p-value. You guys just corrected me and told me I got one more step because this is a two-tail. I got to multiply this times 2. So here we go. Equals, what cell is that? C4? C4 times 2. Here we go.
What
0.04. Go ahead, say it again.
Can I see what's in C4?
Yeah. Equals NORM DIST -2, comma 0, comma 1, comma 1. Now we're multiplying times 2 because it was an equal, not equal to, right? And we get 0.0455. Are you ready? Look at these two sentences. Can we reject the null hypothesis? Yes or no? Wait, where are you? Are we recording? Hang on. You all spoke at once, and I couldn't hear any of you. Let's try again. Can we reject the null hypothesis?
Yes.
Yes. Why? Because 0.04, I can't see it, 55 is less than 5%. Boom. Done. You just did your homework. Oh my God, this is too easy. You want to go home? Yeah. Yeah. Feel free. I don't know. That's all the information you need, but I want to do a couple more to make sure you get it. All right. You ready? Hang on, where's my next one? What are we on, slide 14? No, we're on slide 20. I'm going fast. Slide 25, I think we have no. Well, let's just see what we got here. So here's where it says, oh, here's p-value approach. Okay, here it is. It says, okay, we calculated the p-value of 0.0228 like we did, but now it's doubling it. See how it's doubling it? 0.0456. We got 0.0455 though. We get more, I think, is what we got. Same thing pretty much. And then we compared it to 5%. Is there a sentence here? Hang on. Where is it? Here we go. 0.04 right here. 0.0456 is less than 5%. We reject the null hypothesis. We reject the null hypothesis. It means there aren't an average of 3 TVs per household. We just proved that it's different than 3 TVs. Matter of fact, we probably proved it's less than 3 TVs is what we proved. And I want to tell you, in reality, I think there's more than 3 TVs per household. I mean, I have old TVs down my basement. I don't know if they count.
Yeah, that's what I was wondering.
I got 5, but they count the 2 down the basement that I haven't turned on in a decade or more. Are you getting this? Let's do another.
That little symbol that's next to the less than sign and reject the null hypothesis, what is that?
I can't, that symbol right there?
P value is less than symbol and then comma rejected by.
Oh, that symbol is the significance. But, you know, as you can tell, the symbols are different in your book, sometimes in PowerPoint, so I'm just using words. But it's the significance. If the p-value is less than the significance, you must reject the null. If the p-value is greater than or equal to the significance, you do not reject the null. That's the golden rule. That does not change on any of these p-value problems. You're gonna do you gotta learn how to do p-value for number 1 when you're given the population standard deviation. You gotta learn how to do p-value when you're given the sample standard deviation. You gotta learn how to do p-value when you're using proportions with no standard deviation. And you gotta learn the second approach that we're gonna learn next week called the critical value approach. You gotta learn to use the critical value approach when you're given the population standard deviation. You gotta learn to use the critical value approach when you have the sample standard deviation. You gotta learn to use the critical value approach for proportions with no standard deviation. And the third approach is called the confidence interval approach, which you're gonna find easy because you did confidence intervals the first 3 weeks. The last step involved in this is you're doing confidence intervals just like you normally do, and then once you get to the intervals just like you did in the first 3 weeks, the last part of it is to say, what was this number in this? Was this like $606? The last part would go, okay, I have my upper interval and I have my lower interval. Does $606 fit between these two numbers? If it does, you can't reject. If it's outside your 2 interval numbers, then you must reject. That's how this third one's done. You actually have already kind of learned it. Don't get me wrong. If not next week, the week after, we're going to do several examples of these so you can see exactly how this is used. But you got to know all 3 approaches for all 3 of these hypothesis testing. So the hardest part about quiz 2 is recognizing which one of these you have, then writing the null and alternative hypothesis, then calculate your test statistics, then you either are going to use the p-value approach. It's going to say solve this one using the p-value approach, or it's going to say solve it using the critical value approach, or it's going to solve it using confidence interval approach. Trust me, on that quiz 2, you're probably going to have 3 different problems, 3 different hypothesis testing, and you're going to have 3 different approaches you got to prove you can use.
So would it be the same in the first half and just the?
Yeah. Here's an example. I think if I'm understanding your question correctly. Let's say we're doing this week's homework and we're doing the p-value approach. Well, next week, if I gave you the exact same problem and I said now use critical value approach, you're good. If the p-value approach said you're rejecting, the critical value approach is going to come out saying you're rejecting. Or if I say now use confidence interval approach, it's going to tell you to reject. All 3 approaches always come to the same conclusion. If one says reject, they're all 3 going to say reject. If one says you can't reject, all 3 are going to say you can't reject. It's just 3 different ways to get to that conclusion, whether you reject or not reject. But right now, you're focusing on the p-value approach only. For this week's homework, all I'm asking for, we're going to read them real quick because I want to make sure that's all I'm asking for is for you to do the p-value approach.
So on the quiz, you're gonna say what approach you want us to use?
Yes. I'm going to give you a problem, and you've got to decide which one of these to use, but part of it's going to say, and solve it using the p-value approach, or solve it using the confidence interval approach. I'm literally going to tell you which approach you have to use to solve that particular problem. So that's why you got to learn all 3 of them. Believe me, I wondered, how do you guys feel about the first quiz? Did you feel it was easy or hard? It was pretty easy? The only hard part was maybe the time?
Yes.
Yeah.
35 minutes? Well, after I realized I couldn't come to class, I cut the thing from, I think I had it at 50 minutes, down to 35 to try to help Professor Rowe for subbing for me, so it wouldn't be such a big deal for him to be here the whole time and stuff. So actually 35 minutes for the problems you had. I think there were 6 problems, right?
Yeah.
And out of the 6, I think only 3 were like harder type problems, like the homework a little bit, right? And it came out to really about 32 minutes, and then I just added 3 minutes to give you 35 minutes, hoping that we're all going to get A's on it. Are we all going to get A's?
We're all.
Really? Well, I hope so too. I should have grades posted on Sunday at the latest, I think. All right, so check. I'll put an announcement up. Quiz scores have been posted, so you know to look for them. All right. All right. Hang on. I want to do another example before we go to the homework. Is this the one I want to do? This one right here. Oh, this is almost exactly what we talked about. But here it is. Let's see. Can I make this bigger? Here it is in words. So you can see this is a good example of a quiz 2 problem where you pretend like you don't know that this is the first one. You're reading it and you're got to say to yourself, okay, is it giving me the population standard deviation? Is it giving me the sample standard deviation? Or is there no standard deviation? Well, you know this week is giving you the population standard deviation, but as I'm reading it, I want you to kind of soak it in as to, oh, okay, this is how I'm recognizing this one. You'll see the words. Also, I want you to realize what is the hypothesized mean being given to you and what is the sample mean. Because the sample mean and the hypothesized mean, you've got to recognize which is which. So here it goes. It says, boy, I gotta make this even bigger. There we go. See if this will work. Go ahead.
I just have a quick question. So what's like the key identifier that it's two-tailed?
The key identifier is 2-tail. That's the tough part too. That's the other tough part. Is it 2-tail or 1-tail? The key identifier is usually you'll see nothing about it being greater than or less than or at least or at most. None of those words will be there. And usually the word for the researcher part will say, and they won't think it's different or differs from. The word differ means it could go either way. That's kind of a key indicator is 2-tail also.
Okay, thank you.
So let's see what this says. A research analyst disputes a trade group's prediction that back-to-school spending will average $606.40 per family this year. Okay, so right there, that's the hypothesized mean. Because the researcher is trying to dispute that, saying, no, I don't think it is $606.40. We haven't collected the data yet, but you just read the hypothesized mean value. the part on the right for both of these are always the same number. You never put the sample number up here. This is the same numbers always on the null and the alternative. The exact same number, and it's the hypothesized number. In this case, 60640. She believes that the average back-to-school spending will differ. Everybody see that? Right there, it's just telling you right there, that's two tail. Let me read it though, one tail. She believes that the average back-to-school spending is greater than, now you know it's one tail. Or she believes the back-to-school spending is less than, now you know it's one tail. But this one says she believes the average back-to-school spending will differ from this amount of 60640. You get it? Two tail. So there, you made it through one stumble. Now you're still trying to figure out which type of problem do I have here, but you know it's two tail at this point, and you know the hypothesized number is 60640. She decided to conduct a test on the basic random sample of 30 households. We just have our sample size. Square root of 30 is in this problem, because we got a mean. With a school-aged children, she calculates the sample mean at 622.85. Now we've been given the sample mean. Remember, what we've just been given is not part of the hypothesis. It's that number right there in the calculation on the left side of the numerator. The sample result is that number. Given to us in words. Let me read it again. She calculates the sample mean to be 622.85. Now look at how far away it is from 606. Yeah, it's, what is that? 12, 10, 18, I don't know, what is that, 12? 14, 15, $16 away approximately. But you can't tell. 16 seems like a lot, but you're not sure it's a lot. The sample is not that big. How big is it, 30? It's only 30, it's not 100. So we can't tell by just looking at it without calculating anything if that is significant enough to say, no, it's not 606. We can't tell yet. We gotta calculate this test statistic. We gotta plug it into here. We gotta get a p-value, and we gotta see if it's less than whatever the significance is. Let's see what the significance is. She also believes that the back-to-school spending is normally distributed with a population standard deviation of $65. Boom! Those words right there tell us to go to this first formula, which you know in the homework's gonna be this one. That's all that's on the homework this week is just the first one. But there is an example, like a test question, how you just determined just the first one. She believes that the population standard deviation is $65. You've been given the population standard deviation, not the samples, and not none. It is definitely standard deviation, and it's the population. Well, you're sicker than I am.
It's like one of those coughs, you know,
That's
that
how it
like,
started on me.
you're not sick, but it's just a cough.
You guys, it was
You
the
can't
worst
get rid
thing
of.
I've ever been through. It was the worst thing I've ever been through. I'm now in physical therapy because it all went to my neck, and I'm on a whole bunch of pain pills right now. I don't know if you can tell. My eyesight's blurry. I can't even see anything. That's okay. I can still go. Population standard is 65. She wants to conduct this test at 5% significance. There it is. We have our significance. We know we're compared to 5%. I'm not even going to erase this. We have our significance. We have our standard deviation. We got our sample size. We got our sample mean. We got the hypothesized mean. We can calculate. Before I show you the answer, I'm just going to do it in my head real quick. Ready? Where's the sample mean? 622.85 minus 606.40 divided by $65 over the square root of 30. There it is. That setup is where the points are. Did you guys remember that when you took the first quiz? I wasn't here. Did you remember the setup where most of the points are?
Yeah.
And everybody showed the numbers in the equation, the setup, so I could give you all as much points as possible? Good. All right. That's the same thing for quiz 2. The setup of this test statistic that I just said out loud is where the points are. That's where the points are. Let's see, that would be,
It's one.
that's probably about 1 1/4 points right there just in the setup on a 3-point or 2.5 point problem. So here we go now. We set it up. We calculate the test statistic. Here's our null hypothesis equals 606.40. Not equals the alternative 606.40. We got it. We know it's two-tailed. We're gonna calculate. Where is it? Here we go. We calculate 622.85 minus 606.40 divided by blah 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 1.39. Here we go. Where's the eraser? Is that positive or negative? Uh-oh, we're not even using that equation. We're using this one. 1.39. Is that correct? 1.39 equals 1 minus NORM dot DIST. parentheses, 1.39, comma, 0, comma, 1, comma, 1, parentheses. And say it again. Oh shoot, I thought you were telling me what to do next. Someone tell me what to do after that. Multiply by 2, exactly, exactly. Because it's two-tailed. Let's do it, hang on, I gotta plug it in. Hang on, where's my Excel? 1.39, right? Here we go. Equals, what is it, 1 minus? 1 minus NORM dot DIST, parentheses, positive 1.39, correct? Positive 1.39, comma, 0, comma, 1, comma, 1. Our p-value is 0.082264, but no, we got one more step. Hang on, equals, what cell is that? D6? D6 times 2 because it's two-tailed. Our p-value is 0.1645, almost 16.5%. What is it we're comparing the 16.5% to? Which is how much? 5%. Is 16.5% more than or less than 5%? Can you reject or cannot reject?
Cannot reject.
You got it. Oh my God, this homework's too easy. Oh, what are we doing here? What? Who's done? Oh, you done the homework? Swear. Oh shoot. That would have been good. Absolutely. Let's keep going. See if they said the same thing here. They don't show you the Excel equation. They just show you that they're using the chart still on this book. Using the chart. We're using the Excel. We're not using the Z chart. 0.0823, but then we got to multiply times 2 because it's two-tailed. 0.1646. Are you ready? And your answer should say, it should look like this. What is that? Cents our p-value of 0.16. Give me the rest. I can't see it.
4.5.
Thank you. 4.5 is greater than, this is how you write your answer, it's greater than the significance, you can abbreviate, significance 0.05 or 5%, whatever you want to write there. Let's see, since our p-value is greater than our significance, I need the numbers, we can not reject. It's all about the null. The null hypothesis. Boom. There's your answer. You're showing on your work. You're showing this. You've got your p-value. I can see you calculate the p-value. I can see you're right here that you're comparing it to the significance, and you're telling me you can't reject it. Next week, we got to take it one step farther, but I'll wait until next week. We got to tell what it means to not reject. Next week, we're going to go farther and talk about what it means to not reject. But I want you to focus this week on whether you can reject or not reject. Now, you can abbreviate this whole thing. You can just say p-value 0.1645, greater than, significance 0.05, cannot reject. I'll accept that. You can write the whole sentence out like I did, or just give me your abbreviated answer. But I need to see you're comparing the p-value to the significance. You got to show you're making that comparison. And you got to explain, is it greater or is it less than? Is it equal? And then tell me if you reject or not reject. You can do it, abbreviate it any way you want, but I need to see the elements that you see there. Okay, now, let's look at the homework. Where is it? Again. Is it? Now what's this? A week 4 instructions, we never looked at it. We had a quiz, we have a lecture. There's your homework, when's it due? Monday like usual before 2. There's our PowerPoint slides. We're on chapter 9, part 1. There's 2 chapter 9 PowerPoints. Be aware of that. We're on part 1 right now. Next week we go to part 2. In week 3 we're using part 2. But we're on part 1 right now for this week. Okay, here's our homework. Let's just read these so you can get this. Are you ready? Question 1 is ask you to write the null and alternative hypothesis. That's all you're doing. I don't want to give away any answers. I just want to read one of these to show you how easy this is. Test if the mean weight of cereal in a cereal box is different from 12 ounces. Okay, tell me you can write a null hypothesis and alternative hypothesis by those words right there, especially that word differs. Get it? All right, you know the number's going to be on the right? Okay, all right, too easy. All right, you get 2 of those. Number 2, Consider the following hypothesis. Now this is not a story, this is literally starting you off by giving you the hypothesis. The null hypothesis says the mean equals 100, the alternative says the mean's not equal to 100. Okay? Says a sample of 16 observation yields a sample mean of 96. Assume the sample is drawn from a normal population with a population standard deviation of 8. Stop. If this were a quiz question, you just read that what is necessary to know that you got to use this equation, number 1, because you just got the population standard deviation. That's how you know it's number 1. We don't know, we know it's two-tailed because we literally were given the hypothesis. You can see it's two-tailed, equal and not equal to. So now we know it's two-tailed. We know it's formula number 1 because we got the population standard deviation. What do we got to do? Show your detailed calculations to manually calculate the test statistic. Boom, boom, right here. All right? Then it says, give the Excel equation and the result to calculate the p-value. One of these. Get the result. Write down the equation. Get the result. Explain at 5% significance if you can reject or not reject. Make this comparison. Give me some words. And you only have to do p-value. We're not going to the other approaches yet. We're going to stick with p-value for this week. Does everybody feel they can do this homework question?
How do you assume that it's two-tailed?
Right here where it says, where is it? Simply population standard deviation explained manually. Oh, right there. Oh, it's given to us at the top here. Equal sign and a not equal sign means it's two-tailed. Matter of fact, if you look here real quick, this equal and not equal is always a two-tailed. It's the only one that's two-tailed. Okay, hang on now. It gets a little harder. This next homework problem, I'm not giving you the hypothesis. You have to come up with the hypothesis. It is advertised that the average braking distance for a small car traveling at 65 miles an hour equals 114 feet. Okay, it's equal to 114 feet, but but hang on, we don't know if it's one-tailed or two-tailed. All we know now is the hypothesized number, 114. We got that mean. But we don't know if it's one-tailed or two-tailed because it could say the researcher wants to see if it's greater than that, or the researcher thinks it's less than that. If those words are there, we know it's one-tailed. But if it says the researcher just wants to see if it's different than that, then it's two-tailed. It says a transportation researcher wants to determine if the statement made in the advertisement is false. Okay, it doesn't say greater than, it doesn't say less than, it doesn't say differ. We got to go back to the original question to see if there's a greater than, less than, or equal. In the advertisement, the average braking distance for a small car traveling 65 miles an hour equals 114 feet. So is this one-tailed or two-tailed? Two-tailed, equal and not equal to. There's nothing about it. The researcher thinking it's less than, or the researcher thinking it's greater than, and there's nothing in the original sentence that says it's greater than 114 feet or less than 114 feet. The only word in those two sentences is equal to 114. So we're going with equal and not equal to, two-tailed. Then it says, she randomly test drives 36 small cars at 65 miles an hour. There's our sample size, 36, not the 65, forget about that part. 36 is our sample. And records the braking distance. The sample average braking distance computed to 120 feet. There is this number. That 120 should never be in your hypothesis. Only that 116 is in your hypothesis. Both of these numbers have to be the same as 114. And it has to be that 114. What we just read, that 120, only goes right there, so we can calculate our test statistic. There's the 120, the sample mean. So it says the sample average braking distance on these 36 cars was computed to be 120 feet. Assume that the population standard deviation is 22 feet. Boom. You now realize this is this problem right here if this were on quiz 2, because I just gave you the population standard deviation. That's how you know it's number 1. Now you know it's this formula. Okay. You have all the numbers to calculate it now. Give the null and alternative hypothesis. Show your detailed calculations to manually calculate the test statistic. Give the Excel equation and the result to calculate the p-value, and explain at 10% significance, not 5, this one's 10, whether you can reject or not reject the null hypothesis. Everybody understand what's expected here? Just like the previous problem, but you have this extra step of coming up with the null and alternative hypothesis by how it reads. Okay, there's one more problem in the homework. Boy, I'm making this so easy. If you guys don't do this tonight, you're crazy. You could have it done in 20 minutes easy. because it's so fresh in your mind. Customers at Costco spend an average of $130 per trip. When you get home, open your parents' freezer, because there's been a warning a couple days ago they issued that says, hey, a bunch of people bought these something frozen, these fish or something, and if they put them in their freezer, the dates they would have bought them were like November 19th through November 23rd or something, and they think a lot of people have them in their freezers, and they're going to cause such major health issues. They're trying to get everybody to check their freezers and see if they have this Costco fish. All right, look up Costco fish on your search. Notorious poisoning or something like that. They're trying to get people to check their freezers. When you go home, tell your parents. I'm saving some lights here today. Customers at Costco spend an average of $130 per trip. Boy, that seems low. One of Costco's rivals would like to determine whether his customers spend more per trip. One tail or two tail?
One tail.
Yeah. The researcher or the person at the other company wants to see if they spend more. All right? A survey receipts 25 customers found that the sample mean is 135.25. Now listen, that 135.25 is that number there, not the hypothesized number. These two numbers have to be the same, and it's the hypothesized number, which is 130, that first sentence. That's the hypothesized number. Assume the population standard deviation is $10.50. Oh my God. There it is, number one, population standard deviation. We know we're using this formula. This word quiz, this is your identifier. Are you realizing the identifiers are the same as they were for the confidence intervals? Is everybody realizing that? What you learned about the confidence intervals, how to identify those, is the exact same thing how you identify these. All right? What's becoming harder now is that having to write the null and alternative hypothesis, you know, that's kind of tricky. Hey, is it one tail or two tail? Where's the less than go? Where's the greater than go? Which side? Don't forget, the alternative is what the researcher's trying to prove. That's the alternative. The null is the opposite. Assume the population standard deviation is $10.50. Give the null and alternative hypothesis. Show your detailed calculations to manually calculate your test statistic. Give the Excel equation and the result to find your p-value. Explain using, oh my God, 1% significance. Not 5, not 10, 1% significance if you can reject or not reject the null hypothesis. Now remember, you told me this was a one tail, so when you do this, this is a situation where you would not multiply by 2. You would, whatever you get before you multiply by 2, which you don't do, now you compare that to 1% significance. How are we doing? We okay? All right, no in-class assignment. I'm gonna be busy grading your quizzes. Oh, he applauded for no in-class assignment. I can't believe it. Have a great weekend. I'll see you guys on Monday. If anybody didn't sign in, sign in. If you didn't pick up your.
Okay, yeah.